Hi, everybody. My name is Kelly. I work in marketing at IBWave, and welcome to today's IBWave webinar, Keeping Up with Broadband Demand, where our guest speaker and sales engineer, product owner, David Tucker, will talk about and demo how to make MDU deployments more cost-effective and scalable. And that's it for me. I am going to now hand it over to David, who will take you through the webinar. I hope you enjoy it.
Thank you, Kelly. Hello, everyone. Welcome to our webinar. Glad you're able to join us today. Just a quick background on myself. I've been in the telecom business for about 15 years. It includes a lot of project management, site design, installation oversight, and now working for the IBWave Group to help with our FiberPass product, where we are focused on MDU fiber to the home deployments. 2 years ago, with the COVID pandemic, almost overnight, we saw a 40% increase in internet usage in the home, spurred mostly by the work from home movement. While carriers across the United States have made great strides in the last 20 years increasing access to broadband, studies show that there remains 20 million Americans underserved. Where do we find them? Well, of course, in the remote rural areas, but also in dense urban areas where the infrastructure overbuild costs are a barrier to entry. So not only in the existing dense vertical urban areas, we also find the need for MDU network support in new construction. 2021 had a record number of MDU construction starts with over 500,000 new unit starts. With increasing home prices and interest rates planning to go up this year, we do not see this trend slowing down anytime soon. For example, studies have shown that 70% of millennials currently rent MDU apartments. With these demographics in mind and the increasing technology demands, internet speed remains one of the top 3 criteria that renters look for when choosing a place to live. Property managers also recognize this value, and they see it in higher property values, as well as the ability to increase rental rates for their high-speed internet access and the ability to connect to smart devices. With the pandemic, we also saw supply chain disruption, extreme inflation, and increase in labor rates. So for businesses to capitalize on the MDU opportunity, they have to look for new ways to scale up the business, but without scaling the legacy processes. How do you do that? Well, certainly by improving efficiency and speeding up the process to optimize workflow, effectively communicating and collaborating across teams to execute faster and with less error, and reducing waste and scaling up through standardization and uniformity. And then looking for every opportunity to automate and integrate systems and tools. These challenges translate to the technical and team level as well, whether it's the difficulty in collaborating with customers, contractors, other departments within your organization, or just across your own teams, as various stakeholders are operating on different systems. Accessing project records and managing data, in particular where files of different types by different users are leveraged, files are saved on different servers, local copies are kept, different versions of various files exist on networks, or just managing permission and access to these files. It's difficult to ensure that all team members are working on the latest and greatest files. Also, we see multiple unconnected tools through the process, whether that's the Microsoft Office suite, Visio designs, AutoCAD designs, paper notes, or pictures and videos recorded on user devices. With these multiple tools, we see duplicate entry as we populate data from one form to another, and with that, a loss of productivity and a potential to introduce errors. Additionally, the lack of standardization or the ability to enforce it creates challenges for inventory management, onboarding and training of new employees, inspection of deliverables, as well as the overall consistency of solutions and cost management. Here at IBWave, we look at the full process with a fiber to the home design, starting with a site survey to detailed design and engineering, the generation of various reports, like the bill of material or scope of work, onto the installation phase and ongoing maintenance and management of the network. We assess the deliverables that result from each of these phases and look for a way to integrate into a single design solution that streamlines the process, reduces duplication, and increases the ability to access the latest and greatest information for all stakeholders. And with that, we've developed the FiberPass solution. FiberPass, connected to our Unity cloud environment, creates a space to collaborate and align all stakeholders across the ecosystem. It virtualizes the data that makes it available for reuse across the various deliverables and makes it accessible through other systems with automation and integration. What does this physically look like? Starting with the survey in the field, where surveyors are collecting pictures and taking notes on site, populating standardized survey forms to capture critical information that's valuable downstream in the process for designers, engineers, sales engineers, and management, to starting the design with outside plant views and in-building floor plans, or if the in-building floor plan detail is not needed and we are just worried about getting access into the building and up the vertical, a simplified riser design view approach, to seeing all components in the network and their logical flow through network diagrams, the generation of various reports, for example, our equipment list or bill of material, tracking the tasks with workflow or project schedule, and tasking individuals as we move through each step, to generating an address inventory report that shows all customers on site, and lastly, providing means to help visualize the network build in a simplified, easy to understand layout. All of these are deliverables that we have connected through the FiberPass product to streamline the flow. Okay, to put this into action, we're going to look at two case studies, both performed with major carriers here in the United States. The first one was an effort to help visualize the project more effectively. So we deployed with the customer to 4 MDU sites, looking to address a couple challenges. The first is, how can we speed up the process and reduce the design and deployment cycle? Can we modernize the process and make that data from the project reusable downstream in the project flow, as well as making it available to the larger organization? And then how can we accelerate revenue generation? So compared to the legacy process that required an on-site survey, then passed off to the design team, where a project package would be created and the sales force would re-engage with the building to get approval on the plan, what we were able to show with this integrated FiberPass solution is the ability to go on site and with our mobile tool, collect necessary design information to visualize the project all in one view, taking what was otherwise a 10 to 15 day to get approval from the building owner, building representative, down to just a few hours on site, mapping out the site, placing components, adding annotations and notes, and then preparing a report on site that we were actually able to get sign off on same day, same time as the site survey, and do so in a matter of hours. The success of this led to this carrier investing fully in the product suite, and they are now leveraging it on all MDU builds. Second case study, another major carrier. They had the challenge to optimize the workflows so that they could increase the capacity of the existing team to tackle more projects. Their legacy approach started with a site survey where the surveyors would go on site, capture notes with pen and paper, and take pictures with their smartphones, and then return to the office where they would document the survey in PowerPoint and Word document form. All in, this is about a half day on site, and then about a day and a half before they were able to compile the documentation, resulting in a 2-day span of time before they were able to pass the survey notes off to engineering. Compare that to a trial that we did with the FiberPass tool using our mobile survey capability, able to capture the same information and more in just a matter of a couple hours with a tablet device. With the legacy process following the survey, then moving on to design and engineering, we saw detailed designs being compiled in either Visio or AutoCAD format, typically a day to a day and a half of effort, from which they would have to do manual counts of all scope and material items to generate the bill of material and the cost scope detail, typically using Excel. Compare that to the workflow that we were able to show with the FiberPass tool. Starting with that mobile survey, we're able to upload to the cloud immediately, providing access to the engineering team same day. And then with the pre-design work being done on the mobile tool, 60% of the detailed engineering is already complete. So then with the ability to automate report generation for the bill of material and labor scope, with a matter of just a couple additional hours of work by the engineer, deliver the same package as the legacy process would otherwise take over a week. All right, with the legacy process, 2 days on survey, 5 days for design. The sales force was then equipped with a document package that they could take back to the building owner to get sign off for the proposed solution. This could take a matter of days to even months to gain that approval, especially considering over a week had passed since they were on site and anything agreed to verbally may have been lost by that point in time. Now, compare that to the IBWave workflow, where with the survey and ability to gain sign off on site, we were able to seek customer approval right off the bat, reducing the number of days or even months to approval down to maybe just a mere number of hours. With the FiberPass tool, we have the ability to automatically generate 3D representations of the building and demonstrating how the parts and cables route through the building to help with visualization and the building representative to understand the impact of the network more clearly. Compare that to trying to interpret multiple pages printed out of 2D images of a plan versus interactive 3D model. We took what in a best case scenario was 8 days, boiled it down to a single day's worth of effort, almost an 8x improvement in workflow speed. So with the visualization, the workflow optimization, there's also an opportunity to standardize. At the survey level, that means maintaining consistent, simple formats, taking all annotations, notes, embedding them into a single record, and then ensuring that all users are following the same standardized survey forms when collecting information and providing validation to make sure required fields are being populated. To the design phase, where templates can be leveraged to ensure consistency, and the design data can be virtualized, linked into other steps in the process, automating reports, as well as doing part compatibility validation within the tool, using a tool designed specifically for the fiber to the home application. To look at it needs to standardize with collaboration, providing like a cloud-based online portal to access project metadata as well as project files, maintain versioning, and retain necessary files for longevity. Also, you want to ensure users have the correct access to these files and even provide a means to give access to management for dashboard reporting to check the health of the overall MDU program. Standardization also comes into play for part selection. Ensure that engineers are only designing with approved parts as a way to optimize the cost on the project as well as to ensure consistency. And then this has the downstream effect of improving inventory management and overall reducing material waste. Training is another opportunity for standardization where you can ensure a consistent learning experience and pass along best practices, whether that's online training or in-person instruction. At IBWave, we've accounted for all elements of these, starting with our FiberPass mobile, which is an Android app that can be used on either a tablet or a phone device, our FiberPass desktop design software, or our IBWave Unity cloud collaboration tool. Now, to see each of these phases in action, we'll start with the survey process. Here I have a demo of our mobile tool looking at a project, 2525 Elliott Street Apartments in Denver, Colorado. To start off, you'll create a project, define the project name, and create the project record. From the plans page, typically you'll start from the outdoor plan, identify the building by the address. The FiberPass mobile tool is connected to Bing Maps with the ability to import a satellite view of the site, and then you can crop your attention to an area of focus for the building. Okay, what we recommend as a first step is to first model the perimeter of the building. We'll be able to reuse this as we get into any floor plan design, but it also allows us to hide the imagery layer and still have a representation of the building. Note that as you model the perimeter of the building, the dimensions for the walls are maintained. This is coming from the scale that's loaded with the map source. Okay, with the building perimeter identified, first thing we want to do is annotate from the point of feed in. So we'll drop a push pin and take pictures on site. In this case, serving from an aerial pole with an existing splice case to a handhole at the base of the pole. Annotations include photos, videos, audio recordings, or even just text notes as seen here, where the surveyor can quickly notate information for the site. With the point of feed identified, you then want to capture the route. We have a route part type where we can draw our linear elements, and as you can see, again, the dimensions for that route included. Here we're routing from the handhole at the base of the pole to the southwest corner of the building, where the MDF location or the main utility room is found in that northwest corner of the building. You can see that we can add markup notes directly on top of the plan image, in this case, a simple text box. Here you can see a ruler added showing that imported scale. And then if we click on our reference point in the center of the design, you can see GPS coordinates are preloaded, again, pulling from that map source. So that means that our design and all elements on it are geo-referenced. All right, next step, we want to go inside of the building. If you need to quickly take notes in a single page, single view, we have our riser design workflow, starting with the building info tab, where you capture the number of floors, number of risers, and typical number of units per floor. For this particular building, the first floor is unique from the rest of the residence floors, where we find some amenity spaces, including the lobby, office, fitness, and community room. So we can easily capture those unique spaces in the building. But then you'll see that auto-generated ranges exist for the units on the other floors. With the typical 18 units, we see 201 through 218 on the second floor, and so on up the building. Similar to what we saw on the outdoor plan, we have the ability to add the push pins to capture notes on our riser view as well. In this case, the MDF includes an equipment rack with space for us to add our equipment. Within the mobile survey tool, you have the ability to capture those pictures, but also mark up those pictures with notes as well. Okay, with the MDF captured, next step is to find our telco closets or the IDF spaces. Here we have closet with an existing backboard that we'll be able to secure our equipment on. We found those IDF spaces on the second, third, fourth, and fifth floors. Okay, now there is a horizontal chase spanning the lower level. You can see that there with a pull box. So we need to route from our MDF to the vertical stack or our riser that leads us up to each IDF space. So we can again represent those with routes on the print. Markups to the plan exist here as well. Here with a text box. We also have a freehand pen tool, the ability to draw lines, arrows, as well as simple shapes. So for the horizontal run, we saw a 4-inch conduit from the MDF to the pull box location. and between floors, it's conduit stubs between the floors. Not only can we do the annotations, the routing, and the markups on the prints, we can also add parts directly to the design, allowing for this riser view to be a single design plan if needed. So in this case, we'll place a splitter cabinet in the MDF and 24 fiber MDU terminals on each resident floor, second, third, fourth, and fifth. Now, we'll also want to make note that the 4 units, amenity spaces on the first floor, they are going to route up to the IDF on the second floor. So we'll use our line drawing function and a markup text box to indicate that as such. So you can see from the riser view, you can capture quite a bit of detail, and in a lot of cases where you're entering a building that has existing drop wiring from the closet to the unit, or you're just tapping into existing infrastructure and worried about getting up the vertical, the riser view will suffice. However, if you need to do the horizontal design, for instance, if you're responsible for drawing drops, we can do the floor plan design, starting with the outdoor model as our starting point. So you can see in this case, we have our blue perimeter of the building that we captured on the outdoor print, and we're using that as a starting point for our first floor. If a emergency evacuation plan exists in the building, you can take a picture and load that into the background as an image. From here, it's often useful to capture the various units you are serving. This helps us feed our addressing report and make living unit equipment assignments. And so for the first floor, we identified those amenity spaces, and note that they were automatically named following the unit ranges that we configured from our riser flow. Okay, so next we'll create the second floor, again using the outdoor modeling as our starting point, loading in the emergency evacuation plan. In this case, the second, third, fourth, and fifth floors all share the same footprint, so we're able to reuse the fifth floor plan as our starting point. Again, we'll capture first the equipment area to represent our IDF space, which we find it next to the stairwell along the main hallway there, and then we will sequentially identify the living units. As we place, we have enabled a swipe to extents feature for quickly drawing the unit shapes, and there's also snapping that allow you to quickly connect from one living unit to another, and additionally connect to any modeling walls. So as we flow through, we see the sequential placement of the units following that configured range, 201 to, in this case, 218. The living unit in this case is outlined in green, and that matches the outline for the equipment area that is serving it. As we go to additional floors and create new equipment areas, we'll see a different colored outline. Okay, by selecting the unit, we're able to see custom properties that can be configured. Okay, they're unique for each unit, but we have an ability to set a template for these units. What you typically find is within a building, the configuration of those units is the same and the drop deployment will be similar. So we're able to define that once at a master template level found in that network tab. Now, we made some assignments for the template, and as we navigate back to the individual unit, we can see that those changes cascade across. So as long as you don't break the parent relationship by making an edit at the unit level, it will continue to refresh from that template. Okay, we can also place components on the floor plan. Here we're showing our active devices, or ONT, going into each unit, and then we will identify our route going down the hallway. Now, I personally do not recommend drawing cables on the mobile tool, as we have automated functionality in the desktop app to allow for very quick drawing of any cables connected between components. We also have layer controls so that if, for instance, you want to hide the floor plan image you had from the emergency evacuation, you can do so. And the last unique floor we want to capture here is the lower level, where we find our MDF as well as the horizontal routed conduit over to our pull box. So we create our floor plan, name it accordingly, and again, insert the emergency evacuation image plan, from which we can capture our MDF equipment area that'll be in that northwest corner. With the equipment area, it has a default name that in this case we'll rename to MDF, and then place on the plan accordingly. So you can see instead of that lime green, we now have the purple color for this equipment area. Any units associated back to that MDF will also be purple. Okay, we can recreate the push pin that we saw from the riser plan. So dropping the pin and selecting that picture to represent the rack. And then we will draw our route from the MDF over to our pull box location. Now, you don't have to recreate the push pins. There is an ability to duplicate push pins. So if we go back to our riser view, select that pull box push pin, we can create a copy from the menu in the top right, and then we can move it to another floor. So there's the copy, and then with the relocate, select the floor that you want it to appear on, and then tap to place it in its corresponding location. Okay, with that, it's going to carry over any pictures or notes that were embedded into that first instance of that push pin. Okay, some other tabs here. We have general project properties that we're able to capture in the properties tab. We saw the network tab. This is for setting the template of the unit. We also have custom survey forms. So these are configured in the Unity environment and then allow for a common set of questions for all users to be captured. With the design or the survey notes complete, we're going to generate a PDF report with an option to identify what sections you want to include. And then the resulting report yields first our thumbnail picture for the building, specific project information, our equipment list with quantities and costs, a living unit report for all living units designed, as well as our outdoor plan, indoor floor plans, any annotation pictures that we captured with their markups, as well as the riser design plan. With the survey complete and the report generated, the next step is to then upload the file to the server. All right, so when you have saved the file to the server, you're then able to open it up from our desktop application. What that will look like is open project from server. We're connected to our Unity server location. We'll search for the project of interest, in this case 2525 Elliott. You have an option to create a new design, but also create from a server template, which will preload any picture plan pages with supporting notes or background layouts that you want to use for your page. In this case, we're using a blank template, so just starting a new project. All of our floor plans carry over, and then we have the ability to manage various layers, in this case, turning off the background satellite imagery to get a better view of our layout. We can do our part placement straight from the design plan, in this case, adding our splice closure, which is going to route from the handhold to the point of entry on the building that we're representing with what we call a via. A via allows us to transition from one plan to another. Okay, we're going to connect from our splice case into the building and ultimately land on our cabinet with a cable here drawn point to point, but we can then automate the placement into the route using the cable route magnet. So selecting the route, then selecting the cable, it automatically pushes it in. Okay, next we go to the lower level. We find our MDF, and you can see that that via now exists at the outside wall of the building. Okay, we can create, so we already designed the cabinet on the riser view, but you can see we can assign to a floor. So it essentially creates a sibling that's represented now on a specific floor plan, and then we can move it onto the print. Based on the configuration of this page, the icons for the images are a little too large, so I'm able to resize that down. to get a better representation on the page. Okay, we can also drop a component to represent, in this case, our riser. So our riser essentially takes our floors, stacks it, and then punches a hole through them. So that riser is going to appear on our first floor, second floor, and any floors as we route up the page. Okay, now we're connecting from that via to our cabinet. Okay, and then we need to prepare the additional floors so that we can then connect from our cabinet to each floor. On the first floor, you see these amenity spaces that were not connected to a specific IDF. We can make that assignment in bulk from the desktop application, assigning them up to the second floor equipment area. Okay, now on the second floor, we want to connect from our terminal to all of our end equipment and the devices. We can use that with the Quick Connect tool. With the Quick Connection tool, you select your source, your destination, the cable you want to use, and then the route that you want it to follow. And you can see there, it made 18 drop connections very quickly through that automation. Okay, now instead of drawing this floor 4 times over for floors 3, 4, and 5, we're able to duplicate. And I recommend waiting until the entire floor plan is complete with all equipment loaded before doing so, as it'll prevent you from having to go back in floor by floor. Okay, with those additional floors set up, the next step here is to connect from that cabinet to the terminals. That can be done from the floor plan view, but often made easier by doing it from a single page. In this case, our network diagram found in the design plan. There are a few tools that we can use to organize this design plan. The first we see here is the design plan organizer, creating a table similar to what we saw for the building representation in the riser view, but we're able to organize each floor's components into the associated spaces. Okay, we'll move our elements onto the plan accordingly, and then we're going to grab all of our terminals, move them out of the way so that we can clean up the ONT layouts. Okay, to do so, we'll grab all ONTs on one floor, and then with the automation tool, we can arrange these elements in an array. So we'll set our horizontal and vertical spacing as well as the row stacking. And when we hit apply, it'll transform the selection into that matrix array. Okay, they're all still selected, so we can move them as a group. In this case, I decided that, hey, I want some more spacing vertically so that I can clean up my drop lines. So I increase the vertical spacing, apply it, and you see that the spacing is widened between the 2 rows. Okay, now all of our drops route straight back to our terminal. So we'll want to come back and clean those up, where we can again use our cable route magnet. Okay, so once we have organized all floors using the automation tool, then we'll come back and we'll draw some routes and then again use that cable route magnet tool. So with our routes, we'll do a horizontal representation for the hallway. We have a generic route function seen in the network tab, but we can also do part-specific cable routes. So if you are physically adding conduit or a chase, you can load those from your parts and they will automatically populate into the bill of material. So with our routes drawn in, we'll again use that cable route magnet tool, and we can grab all of those drop lines and then clean them up by pushing them into the route. Okay, with that complete, we now have our design plan well organized, making it easier to then connect from our cabinet to our terminals. So we'll again draw a cable route to represent the riser span, and then make sure our pull box is in position. And then we can again use the quick connection tool. So as I mentioned earlier, we used 24 fiber terminals. From each terminal, we're going to have a cable stub run into our cabinet. So we can draw that with the quick connect, selecting our source, our destination, the 24 fiber cable we want to use, and then the route we want it to follow by hitting apply. it does our automatic routing for us. Okay, now if you go floor by floor, you'll see that each terminal has been connected back to the cabinet, routing through the riser. That is essentially design complete, so now we just need to add some supporting pages. For example, our automated bill of material, we can create a picture plan for additional notes, and then our equipment list BOM can be added to that picture plan as an embedded subreport. So you see that here loaded in with all of the components that we had represented on our design. Additionally, we may want to show all of the living units for the project, so we'll create an additional picture plan and add the embedded subreport for our living units. There are multiple fields you can select, and you also have the ability to reorder from this options window. In this case, we'll leave the 3 defaults and then show for the address and the associated equipment area the specific units. You can see that we also not only had the 2nd floor, but now the 3rd floor, 4th, and 5th floor units were included. Some final cleanup we might want to do is add legends. Legends can be auto-generated and show only the components that are listed for each plan page. So you can see between our point parts as well as our cables, those are represented. And then I can quickly copy and paste the legend from floor to floor. Okay, and then finally, a consolidated report showing all detail can be done with our annotation report functionality. We can select the specific pages we want to include, and then we generate the report. This is exportable to PDF and other common file formats to include Microsoft Office, PowerPoint, Word, and others. Okay, all of our floor plans carry over. If floor plans had any annotations, any pictures, those will show up on the right-hand side of the screen. And then the layout that we embedded this in can be customized to suit your specific needs. We also see our picture plan reports carrying over with the equipment list. And then lastly, as we had showed before, with the design and having captured the building perimeter with modeling and loaded all of our components in, we can quickly generate a 3D representation of the building that shows all of our floors, all of our parts, and how the cables route through the building. This again helps ease in the visualization for stakeholders and building owners to understand the impact of the network on their building. With the design now being complete, we will then save to server where we can access in our Unity Cloud Collaboration Hub. When you log into Unity, you get a project tile view of all your associated projects. If they are saved per folder, that's available on the left-hand side. Otherwise, we can search for our specific project, starting with the site, then drilling into the project detail. We can see the project information associated with the site, or from the left-hand menu, we can look at the plans and buildings from Unity. So for supervisors, managers to see the plans, they don't necessarily have to open up the design file. They can also see the component list. Managers can also navigate to this dashboard view to see the overall health of the program. Each dashboard report being generated from these reports here under the report tab. And then we can also apply workflow and tasking, starting with a workflow template assigned to the project that will have the various tasks, the owners of those tasks, and the proposed duration to help force automation of the flow. From the administrative tab, we see here the ability to create roles where we can control privileges within the application, as well as set permissions for the various project folders. So that's just a brief glimpse at what the Unity tool can do. To take a look at future integration, we'll talk real quick about GIS. So GIS, Geographic Information System, you often see these managed by municipalities for managing parcel data for quick online searching, but you'll also see a lot of various tools within the OSP design space that leverage GIS technology, as well as engineering record systems that might be GIS based. where FiberPass is designed to capture the MDU and in-building design, there is also a need to represent that same information in a GIS OSP design environment. So there are design tools on the marketplace that are GIS based and optimized for the outside plant. However, they do not well account for the MDU deployment. By enabling GIS integration with our MDU projects, we're able to view all of our sites from Unity in a Unity viewer, Unity GIS viewer embedded in, where we can navigate to specific project sites, select the site, and then select the associated buildings in the site where we can see the floor plan level detail. So in this particular instance, showing the building details, we can, from the drop down, select different floors, and then we have layers representing the information that carries over from the design. Okay, so this viewer is embedded within Unity and will be a part of our 18.0 release scheduled for April. But there is also an API module that can be purchased that will allow you to export all of your design data out from Unity and import into a native GIS system. That GIS API module, so if you're not familiar with an API, application programming interface, this is a software intermediary that allows two applications to speak to each other. So essentially a way to transfer information from one system to another. In this case, it might be the design detail from the plan itself, project properties, documents and reports, or even the tasking and integration data that you might want to pass to other tools. Within Unity, you can access a list of APIs with instructions for how you are able to move the data either in and out of the Unity tool. An additional integration here, if you are able to receive a drawing from the building representative, often it'll come over in either a CAD format or the new BIM format, which we're starting to see as the architectural drawing standard. So the BIM is a 3D file that gives you a very good visual representation of the building. We are currently implementing a BIM import functionality where from the desktop tool, you're able to import from your files, select the associated BIM file record, identify the corresponding views, and then select the layers that you want to import with a material type assignment. So you can see here with the first floor selected, the layers available on that floor are available. Select the ones you're interested in, and then you can make a material assignment that will allow that layer to be represented on an import into the FiberPass or IBWave design application. So you can see we have the graphical detail, but it is just carried over as an image. When we turn off that image layer, we see the corresponding walls carry over. By selecting the wall, you can see from the properties the material assignment that we made, which aids in the visualization. But then by going to the 3D view, we can see how detailed elements such as doors, windows, and the corresponding walls are now represented. Okay, so we have the 3D view, but we also have the ability to push back into the BIM layout. All right, so visualization, where that's critical again, is helping the building owner, building representative understand the impact of the network to the building, allowing you to get to that approval faster. This also within your own teams, helping to communicate what the deployment needs to look like, helps in a greater understanding for the build and improving the quality and speed of execution. We looked at how through an integrated survey and design tool, we're able to optimize the workflow and reduce duplicate entry of data by having a all-in-one design file. And then through the Unity Collaboration Hub, how we can make access to the data and the project files a lot easier, making sure everyone is working off the latest and greatest record. And with that, that concludes the presentation for today. I appreciate everybody listening in. Hopefully it is apparent how, while FiberPass is one way to represent this, there are specific best practices that we look to leverage to optimize the workflow, to improve quality, to improve speed of execution, and overall reduce errors as you work through your MDU fiber to the home deployment process.
Great, thanks so much, David. So it doesn't look like we have any questions so far. We have a couple of comments saying excellent presentation, good material. I'm just going to give everyone a few seconds here to send any questions that you might have now that we're at the end of our presentation. So go ahead and send them if you have any. Just wait a couple seconds here. Okay, it doesn't look like we have questions, which means maybe, David, you covered everything so well that it's just crystal clear. So we have 10 minutes to go before the hour, so we're going to let everyone go and end the webinar at this point. Thanks so much, David. Appreciate you taking the time.
If there's any follow-up questions, don't hesitate to reach out to your IBWave team.
Absolutely. Thank you. Have a good day, everyone.
Thank you.